Hello everybody, Chris here, and in this video we're going to be covering vector shape nodes inside of DaVinci Resolve 17. So, of course, because we're talking about nodes, that would imply fusion compositions. So you can bring these vector shape nodes to add shapes and shape modifiers over on the fusion page for either a clip that is already existing or a new fusion composition clip. So when you want to start completely from scratch, you would use a fusion composition clip instead of modifying a base clip, like just a regular video you recorded. If you want to create a fusion composition, then we go over to the effects library, and then you go down Toolbox, Effects, and Fusion Composition. So this is essentially a completely blank clip that serves no real purpose other than to allow you to build Fusion node effects inside of the Fusion page. So to start adding vector shape nodes, you would click on your Fusion composition and then you would go over to the Fusion page. I already have a Fusion composition with every single one of the vector shape nodes set up, so I'm going to use that to explain things for the rest of the video. So I'm going to use this and go over to the Fusion page. So on the Fusion page, if I zoom out and show this node graph, you'll see I have a bunch of different setups. We're going to walk through each of them and I'll try to explain what each node does as best as I can. So the first one that we have actually feeding into the media out, you'll notice that when you're using vector shape nodes, and by the way, all the vector shape nodes you can find by right-clicking on the node graph, going to Add Tool, and then go down to Shape. And here's where you'll find the shape tools, all indicated by a S as a prefix to each of the individual nodes. But you'll notice that on all of these setups, that I have a sRender node. So in order for vector shapes to be rendered to an image and actually be part of our final video output, we need a sRender or shape render node at the end of any of our chains. So it's very similar to using the 3D renderer node, where if you're going to create 3D text inside of the Fusion editor, it eventually has to go through a 3D renderer before it can go to media out. So just note that the reason why you can't connect any of these nodes straight to media out is it has to be rendered first with sRender. So let's go to the first node in this chain here. I'm actually going to disable the other two nodes so that we can just explain one node at a time. So I'm going to select this sDuplicate node and turn it off in the inspector, and then the sJitter, we will disable that as well. So now it's effectively as if the shape star node is feeding straight to sRender and then media out. So the shape star node, we can zoom in here a little bit on media out, and we can see that this just allows you to create star shapes. So for each of these vector shape nodes, we have gizmos on the screen indicated by these green lines, which we can use by hovering over the sides of the green line and stretching the width or height. So for each of these shape nodes, we have settings in the inspector we can use to modify the shape, and we also have gizmos which can do the same thing. So if we select the star node, we'll be able to change the settings of that node in the inspector, and also there are gizmos we can use in the viewport window, such as standard transform positioning gizmos. And here as the dotted line, we have the ability to rotate it with an angle. And then on the sides, you can stretch the width and the height out. One thing I really want to point out that may not be immediately obvious is that if you don't see your star node, it may be because you're previewing the shape as the window up here. So if we take the S*1 node and make that our left preview, you'll see that nothing actually displays here. So nothing gets rendered to an image that you can edit until it reaches the sRender1 node. So if I preview the sRender node up on the top left, we'll actually have the shape appear. Now we can click on the star node, and then we'll be able to edit the values of that star node using the gizmos like I just talked about, or to change the values in the inspector. But once again, if you just preview the shape, you're not going to see anything. So make sure that you have a render node so you can actually see what you're changing, and preview the render or the media out node instead. So the rest of this shape is pretty self-explanatory. You can customize the number of points that the star is going to have. It defaults to 6, but you're welcome to have more points. You can set a border width if you want to add or remove to the size of the base shape. And you'll notice that different border styles are going to result in a different overall shape. So if you use the curved ends, then your star is not going to be pointy anymore. It's going to be a little bit more of a lump, but you can still have a border style that has a pointy width if you decide. Okay, so let's go ahead and add in the duplicate node. So as you might expect, the duplicate node allows you to add copies of the original shape, and you can modify it with the offset X position and Y position. So that's why if we look at the render one here, you'll see that the position of these copies is away from the center area. But if I bring back the X offset towards the center, then it's going to be more in line with the original position. You also notice that for every copy, it offsets the position once again. If you look closely, you'll also see that currently with the settings here, the size of the shape goes down in each increment. So the X size is basically a multiplier on the previous size. So if I set the X size to 1 and the Y size to 1, which I believe is the default, then they're all going to be the same size because the size is being multiplied by 1 each time, of course. So if you want it to get bigger, you increase the X size or the Y size, depending on which direction you want to stretch. And if you want to decrease it, then you drop it below 1. And the lower it is, the bigger the size change is going to be per multiple. So if you get too many copies and a X size of, 0.5 or something like that, then you're halving it every single time. And with 5 copies, that's going to half it 5 times and make it pretty much invisible. It's just a little dot there now. So with that many copies, you're probably going to want a bigger X size and Y size. So for the next node, sJitter, I went ahead and reset everything to the defaults, and I'm disabling the duplicate one node temporarily so that we can go step by step in explaining this. So the sJitter node basically allows you to manipulate the X position, the size, the rotation, and then individual vector points on your shape. So if you only have one shape, then basically what you see is what's going to be applied. So if I offset the X position here, it's just going to offset that one copy of the shape. But as the node title jitter would imply, if you have multiple copies of the shape, it will actually go between the two values you see. So on the slider bars, there are 2 points here. So if I put the X offset to the left over here, then what's going to happen is that for each copy of the star, it's going to go between an offset of negative 0.07 and 0. So if I re-enable the duplicate node here, then you'll see that the X offset on the first one does go to the left, but then on the second one, it goes back to the right, and then to the left, and then to the right, and then to the left, and so on and so forth. So basically, it's going to oscillate between the two values, at least in fixed jitter mode. So if I make modifications to the size for X and Y, then it's going to go between stretching the X size to be really small and really large. So that would be why, if you take a look at the left side now, that the size of the stars vary a lot in their actual values. Of course, the duplicate node is still shrinking them overall for each individual one, but hopefully you can see the X stretching there. Shape rotation is also pretty self-explanatory, so it's going to be rotating them at different values between the 2 points we have here, negative 148 and 0. So if you look at this shape right here as we adjust the values, you can see that it's rotating around an origin point, not necessarily the graphic of the star itself, so you'll have to be careful about that. And then the point jitter, that's going to be a modifier that applies to the individual points. So if I point offset here, you'll see that it's not offsetting the shape, but it's offsetting the individual points, and clearly that can get quite distorted, so you'll have to be careful with that one. Of course, you can offset the Y points as well. So that's the general idea of the jitter node. One thing I do want to point out with all of these nodes, though, is that pretty much all of their properties are keyframeable. So if you want to animate any of these values across time, you can do so. So if I take this shape rotate, and we give it an initial value here, we could hit play in our timeline and there'd be no animation, but we could easily set this as the first keyframe value, go, let's say, 60 frames into this effect, change the shape rotation, and now if we go back to the first frame and hit play, then you're going to see that the rotation value of this jitter node changes across time. And maybe we do need the values to be more dramatic than that for it to really be obvious. So let's go ahead and try it now. And now you can see some significant rotation occurring in each of these shapes due to the jitter node. So that's just something to think about if you plan to make any kind of motion graphics with these tools. All right, so let's go ahead and move on to the rectangle and grid nodes. So the rectangle node is pretty self-explanatory. You have a rectangular shape. You can control its width and height. You can also add a corner radius. So this is if you want to curve the corners rather than having a sharp edge. And then you can also give an angle to your rectangles. Maybe you want to make them rotated 45 degrees and make them a diamond. Or maybe you just want them at 0 degrees and just a standard square. So if you want a square or a rectangle or a diamond shape, S rectangle is going to be the node for you to use. And if we zoom out a little bit here, you'll see the grid node in place. So the grid node is going to create copies of your shape node on a grid. So if you want a 3x3 grid, then you would put grid cells 3, so 3 going horizontally, and then grid cells Y3 is going to create a 3x3 grid, and you'll get a total of 9 copies of the shape. So we can also increase one of the numbers here if we want to get more copies of the shape, or decrease them. Now, the only other setting here to note is the X offset and Y offset. That would be this gap space you see here. So if we want the gap to be smaller, we simply lower the X offset. Probably better to use the number here for finer tuned adjustments. And Y offset, similar things. So if you have a smaller offset, you can probably add in another row or column for your grid cells. And then, of course, we're able to see it because we have the sRender node. So just don't forget about your sRender node before you go to media out. Okay, let's come up here now to this set of nodes. So I'm going to disable the sExpand node temporarily, and we'll take a look at this NGon node. So an NGon is a polygon that has any number of sides. Whatever number you specify is the N. So that could be a hexagon if you have a 6-sided NGon, or you could have 8, which would be an octagon. You could have 7, which I'm not sure even has a name, but technically you can have a polygon with any number of sides here, or at least up to 20. At that point, it basically becomes like an oval shape. And at 3, it would be a triangle. Below that, it wouldn't display anything. So I guess that's not possible. So once again, you have similar controls to the rectangle node. You can offset the position. You have width and height if you want to stretch it in one direction. And you can also use angle to rotate it. So then I have this feeding into the sExpand node. So with sExpand, you basically add to or remove from the information on the outer border. So it's similar to having border width and style built into the NGon node. Maybe you want to merge 2 nodes together, and then you want to use sExpand to control the border width on both of those nodes at the same time. That might be one reason you would use sExpand instead of just modifying the border width on the base shape node. So obviously we can increase the amount here if we want to expand the border. You can once again choose the border style if you want it to be pointy or curved. And if we go the other direction, a negative amount is actually going to be taking away from the base shape. When you do have a negative amount, though, the border style isn't going to come into play here because there is no border, it's just removing information. So now we can come up here to the ellipse shape and the Boolean nodes. So you can see I've created basically a moon shape here by using the Boolean node. Let's go ahead and disable the Boolean so that we can see the base shapes. So if I click on these 2 shape nodes, we can see the original shapes that we used to create that moon. The first one, just a circle. So an ellipse, it can be a circle or it can be any oval shape. If you want it to be a non-circle oval shape, you would just make the width and height settings different. So you can see here, if you increase the height, it's going to look a little bit more like an egg, for instance. Same as all the other shape nodes, you still have X offset, Y offset, and angle. If we click on this ellipse 2 shape here, you'll see that it's not visible because right now it's serving as the subtract component of the Boolean nodes. So with the Boolean modifier node, you're able to do things like remove one shape from the shape of another, and that's how we would get a moon. So you can see how this shape is basically subtracting from the underlying shape, kind of serving as a mask, so that the area that they overlap in just does not show in the final area. So if I re-enable the Boolean 1 node, you see how the ellipse 2 subtracts from the area of ellipse 1. And that's the idea of the subtract operation. Of course, there's also things like intersection, where it'll only show the areas where the 2 overlap. You can do union, where you add the 2 together to get the final shape. And then XOR operation are going to be all of the areas for both of them, but not the areas where they overlap. So this overlapping area doesn't show, but the outer areas do. And by using the Boolean node, obviously you can create some pretty interesting shapes that would be kind of a pain to do. If you were trying to manually create something like a crescent here and warp it with other tools, it may just be easier to do it with the Boolean node, adding or subtracting one shape to another shape in order to create completely new graphics that you can use in your videos. All right, so that's about it for those 2. Let's go to the outline node. So the outline node basically takes your base shape and only shows the border of it in the final render. So we have an ellipse node here, and obviously you can imagine that without the outline node, well, you don't really have to imagine, I can just disable it. The ellipse is going to fill all of the area within its base border. But what the outline node is going to do is to take that outline shape and to only render that with a line that draws over it. So if you've used any programs like GIMP or Photoshop and you had a path and then you tried to stroke that path with a paintbrush, it's very similar to that. You're just taking the path that would outline a shape and you're rendering that as if you had drawn a stroke across the shape. And then everything inside the fill area, that gets excluded. So if you needed something like a ring or a shape that just isn't filled in, then this would be the node you go to. Okay, and now we're coming close to the end. So we have two more NGon nodes here. Don't need to cover that more. They're just 6-side hexagons. But the node here that we do care about is the S merge node. So whenever you need to combine two nodes into one node, for instance, if you want to render two shapes at once and you don't have any other node, such as the Boolean node, which already combines them in some operation, then you can use the S merge node to combine them normally. So here we have two shapes and they just layer on top of each other. So the merge node just allows you to take all of the inputs, and you can see that you can actually have more than two, to take all of those shape inputs and then to combine them into one output. So in a way, it's quite similar to having the S-Boolean node in union mode. But basically, if you just want to take your shapes and you want to include them all in the final output, but you can only feed one into your shape render node, then the merge node is how you can achieve that in the simplest way possible. Also, being able to take 3 or more inputs is going to be helpful. The S-Boolean node, as you can see, can only hold 2 inputs. So if you have 3, 4, 5 shapes, then it's going to be even easier to use the S-merge node. So if you don't need some operation on it and you just want to include all of them in the output, use S-merge. All right, before we wrap up the video, let's go ahead and check the Add Tool menu. So right-click anywhere that's a blank space on your node graph. Go to Add Tool, and then down to Shape. Let's make sure we covered all of them. So S-Boolean for those operations, duplicate to create copies with offset and size modifiers, ellipse, expand, grid, jitter, merge, NGon, outline, S-rectangle, S-render, S-star, and S-transform. Okay, we forgot S-transform technically. So it was over here. Let's go ahead and put this on render 2. So the S-transform node is really, really simple. It's a transform modifier for any input nodes. So for instance, if you had the merge node over here, and then you put it into a S-transform before it goes to the S-render, then because these two NGons were merged together before it got to this point, that transform node is going to be applying a modifier on all of the earlier shape nodes in the chain. But aside from that, the S-transform basically has the same settings that you would see in each individual node. So for instance, that would be like the X offset if you want to change the position of the input, X size if you want to stretch it horizontally or vertically. Okay, and then we have rotation. So you'll see that the rotation occurs around this little pivot point, which is set with an X. So if I add rotation, it's rotating the object around that center point area. But if we offset the pivot, then that is going to adjust the rotation. So you'll see now that it's kind of rotating around in a circle because the pivot point is right there in the middle of the shape. But if we put it way to the outside here and now we do rotation, then now you can see it's kind of orbiting it again. So wherever that X pivot point is going to control the rotation. Of course, that also applies to the Y pivot. So if you want the pivot point to move vertically, then you can do that. And now we can have it rotate around that pivot point again. It's just that the Y pivot changes its position up, down, rather than left, right. So with the S-transform node, you can have that apply to one single shape node that comes up in the chain like this. Or once again, we can put that over after a S-merge. So might as well do that here. And now the S-transform will just affect the position of both of those objects. So if I offset it, you'll see that we have 2 NGons and they both move with one transform, as opposed to going to the settings for one of the transforms individually and offsetting the position. So you can see the difference. If you put it further up the chain, it controls everything in that node chain. So that's going to be it for this video covering the basics of the vector shape nodes that were added with DaVinci Resolve 17. Hopefully you can get an idea of how these could be used for motion graphics, being able to add shapes to a 3D composition and animate them around your screen using all of these nodes in conjunction. One thing I forgot to mention, and I'll just cover this really quickly, is that for each of your shape nodes, you can go over to the style if you want to give them a color. So you can see by default they're white, but they don't have to be. If you need them to be a different color, you can just go in there to the color selection tool, change the color. So whatever kind of graphics you want to make with these vector-based shapes, you're going to have full control over how you want to implement that. As far as I've seen, pretty much every property is animatable here, so it's going to be quite flexible. And I think that's just about it for the basics of these vector shape nodes, what each of them do, and a general idea of what you can use them for. So I've been Chris, thanks for watching, and I'll see you guys in my future video content.